Kia ora, guys. So for week 3, the final thing we're looking at is linear inequations. So we're going to go through these 2 exercises. I'm going to pick a couple of examples randomly from the second exercise. But for the first part, let's just look at the concept. The whole idea of an inequality is that it's not equals. It just means not equals. So it can be less than, and it could be greater than, or it could be less than or equal to, or greater than or equal to. These are all inequalities. Best way to remember is the crocodile, because they're greedy, the crocodile will always eat the bigger number. So when given the choice, crocodile. If he's given the choice, or she is given the choice between an 8 or a 4, the crocodile always eats the bigger number, right? So if I have this, it means that I'm going to put the smaller number on this side and the bigger number on that side. Crocodile always eats the bigger number. That's inequalities. So let's have a look at the examples. So let's start off with a real simple one. We know that 4y is less than 12. When we're dealing with inequalities, we follow the exact same rules with one exception. So here, there's no exception. So we can just divide this side by 4, divide this side by 4, and we get y is less than 3. But if we had an example like this, if I say I had negative 4y is less than 12, this is where the exception comes into play. So if I'm dividing by negative 4, because that's how I'm going to have to get rid of that negative there, the inequation sign flips. And I can show you an example of that, but let's just do it first. So that means we're going to get y is greater than negative 3. So when we divide this by negative 4, we get that. So the only exception is that this symbol flips when we're dealing with a negative. So whenever we times or multiply by a negative, we flip the inequation side. And I'm going to show you an example. So we know for a fact that negative 2 is less than 1, right? But if I went and I times this number by negative 1, what happens here? What happens is we get a 2 here, and we get a negative 1 here. And we all know that a crocodile would choose to eat the 2 rather than the negative 1, because the crocodile wants the bigger number. So that just shows that the inequation sign flips when we multiply by negative 1 or when we divide by negative 1 or any negative number, right? So hopefully that makes sense. Let's look at an example. So for exercise 1, we are going to have a look at this one. X plus 2 over 3 is less than or equal to x minus 2 over 6. So we're just going to follow the rules as usual. So we've got divide by 3 here, and we've got divide by 6 here. If I multiply everything by 6, I think I'm going to be able to get rid of the 3 and the 6 at the same time, which I think is pretty useful. So these things are just going to cancel each other out, but let's have a look at it first. So here, if I have x plus 2 divided by 3 times 6, so divide by 3 and times it by 6, we're still going to be left over with an extra 2 here. So it's going to be 2x plus 2. That's left over, right? Because first of all, we're timesing by 3 to get rid of that, and then we're timesing by 2 because that's the leftover from our times 6. So over here, everything just cancels, so it comes out real nice. It's just x minus 2. Let's expand the brackets. So we're going to get 2x plus 4 is less than or equal to x minus 2. I've got a bigger positive x over here, so I'm going to move that x to this side by minusing x. Over here I want to get rid of that plus 4, so I'm going to minus 4. So let's just make sure those sides both balance. Perfect. So 2x minus x is going to get us x. These cancel, these cancel. Negative 2 minus 4 is negative 6. Notice we didn't need to flip the inequality sign at any stage there because we didn't times by a negative number or divide by a negative number. So it just worked the same as an equal sign would have worked. Okay, let's pick a random wordy question from here. I'm interested in John. Let's see what John's up to. So for exercise 2, question 6, x2, question 6. John buys 7 cups of tea and 4 cups of coffee for his co-workers. He pays $29.60 altogether. A cup of coffee costs 25 cents more than a cup of tea. Calculate the cost of a cup of tea. That doesn't look like an inequation question at all. But let's have a look. So, he's buying 4 cups of coffee. I'm going to make C equal coffee. Yeah, no, it's a pretty big move, but we'll get away with it. I'm going to make T equal T. So, I know that he's buying 7 tea, and I know that he's buying 4 C. So, when those are added together, so that gets us a monetary amount, which is $29.60. Now, C doesn't actually equal coffee. It doesn't equal how many coffees. Because we're dealing with money here, it means we're dealing with the price of the coffee, and that must be the price of the tea. So 7 times the price of the tea plus 4 times the price of the coffee gives us the overall cost. So what we're going to do is if a cup of coffee costs 25 cents more than a cup of tea, so C equals T plus 0.25. I don't know how this is an equation. Maybe we're dealing with something different. These are just simultaneous equations. Oh well, let's keep going. Look at this. We've got an expression for C now. We know that C equals this whole bunch of stuff. So we can just substitute that in where C is. So let's do that. 7t plus 4, we'll substitute t plus 0.25 equals 29.6. I may be off the screen, sorry. Expand 7t plus 4t plus 1, because 4 times 0.25 is 1, equals 29.6. 11t, and then I'm going to plus 1 equals 29.6. I wanted to do that faster, but it's too late now. 11t, I'm going to minus 1 off both sides, equals 28.6. T equals 28.6 over 11. I don't think I can do that in my head. Don't worry, I've got this. No, it's a lame calculator. Sorry, guys. 28.6 divided by 11. We now know that T costs $2.60. So how much is coffee? It's T plus 0.25 equals 2.6 plus 0.25 equals, oops, let's show you the camera, $2.85. So now we know that the price of coffee is $2.85 and the price of tea is $2.60. That is not an inequality, so I don't know what we're doing. These are all equations. I don't see any less than or equal to's here. Okay, so we moved on to a new topic. Exciting. Alright, that's all for now. Thank you, goodbye.